Let's now look at this new term called chord of contact. Now here I would like to draw your attention to the fact that whatever the terms we are learning, tangents, normals, pair of tangents, chord of contacts, everything else that we will see later, you will not just be using them in circles, you'll be using them in parabola, in ellipse and in hyperbola, right? 3 more chapters. In fact, you will be surprised to know that the formulas that you are learning will be the same for all the 4 cases. So for instance, if you learned that the tangent to a curve at a point x1, y1 is s1 equal to 0, you learned that for circles, it will be s1 equal to 0 for parabola, for ellipse, for hyperbola, all of them. Right, so we did learn, right, that if we have a circle and at a point x1, y1, if I need the equation of the tangent with circle's equation being s equal to 0, then the equation of the tangent is s1 equal to 0. We've learned that if the point is on the circle, right? Now this is valid not just for your circles, the same result will be valid for your parabola, ellipse and hyperbola. So that's why when you learn circles, learn all of this perfectly, so that in the other 3 we can just rush through them, just referring back to circles. So we won't be deriving them in detail there, but we can just rush through. So just remember the formula. So now we are coming to chord of contact. What do you mean by chord of contact? So from a point outside, if I draw a pair of tangents, so these are your pair of tangents, this AB and BC. B is where your first tangent is touching the circle, C is where your second tangent is touching the circle. So AB and BC are your pair of tangents. If through this BC, if I draw a line, this blue line is being drawn through those point of contacts, then that is called your chord of contact. So basically, line through points of contact. That is basically your chord of contact. So how do I get its equation? That is the question. So first of all, let's find the equation of AB. So AB is a tangent at B, right? So basically put s1 equal to 0. Use s1 equal to 0 at x dash y dash. So this is your circle, x square plus y square equal to a square. Basically this is your s. How do you do s1 equal to 0? X1, and because this is your x dash, so x dash plus y dash minus a square equal to 0 is the equation of the tangent passing through B. Similarly, what is the equation of the tangent passing through C? Do s1 equal to 0 at C. So this time you will do x into x double dash plus y into y double dash minus a square. I hope you are following this. So this is your AB, this is your AC. Right. Now, because this AB and AC, they are both passing through A. Right, they are both passing through A. So A, which is your x1, y1, must satisfy the equation of both AB and AC. Right. So that is what I have done here. So here basically this is your equation of AB, the first one, and this is your equation of AC. So what I have done is I have put the coordinates of A, x1, y1 in this equation. So if you put x1, y1 in this equation, it will become x1 x dash plus y1 y dash minus a square equal to 0. If you put x1, y1 in this equation, it will become x1 x double dash plus y1 y double dash minus a square equal to 0. Right, because x1, y1 must satisfy both this and this, because both of them are passing through passing through A. Right. Now, the more important question is if these two are holding good, that means your B and C both lie on this line. So what are your coordinates of B? B's coordinates are x1 x dash y dash. C's coordinates are x double dash y double dash. I am saying that both B and C lie on this line. So you can verify that, like you can put x dash y dash. So if you put x dash y dash in this, you will get x dash into x1 plus y dash into y1 minus a square equal to 0. Does it hold good? Yes, it is holding good from here, right? Similarly, if I put x double dash y double dash in this equation, then I will end up getting this equation. So even x double dash y double dash satisfies this. So both these points satisfy this line. That means this itself is the equation of the line passing through them. So this itself is your chord of contact, because this is a straight line which is satisfying both this point and this point. And you can have only one straight line passing through 2 points, right? So this itself is your chord of contact. Now if you look at this, this is also s1 equal to 0. Just that it is your s1 equal to 0 is keeping this point as your reference. So when you did s1 equal to 0 here, you took this point as your reference. When you did s1 equal to 0 here, you took this point as your reference. And finally, for your chord of contact, you're doing the same thing. You're doing s1 equal to 0, but you're doing that with this point as your reference. So next time when you see a circle and a point outside, and if I ask you what is the chord of contact passing through, chord of contact with respect to this point, just do s1 equal to 0, right? And you'll get the chord of contact. Now, how is it that the equation of the tangent is also s1 equal to 0 and equation of the chord of contact is also s1 equal to 0, right? So we saw equation of tangent is s1 equal to 0, and for chord of contact also it is s1 equal to 0. Yes, the question is, if your point is on the circle, then s1 equal to 0 will give me the equation of the tangent. But if your point is outside the circle, then s1 equal to 0 will give me the chord of contact. So this is the difference I want you to note. So even in these two, your points B and C were on the circle. So that is the reason why, so this point B and C, they were on the circle. That is the reason why doing s1 equal to 0 was giving me the equation of the tangents passing through these two. But the same s1 equal to 0 for this point will give me chord of contact because this point is outside the circle. So when outside, s1 equal to 0 gives chord of contact, and when on the circle, s1 equal to 0 gives the tangent at that point. So this is one important point I want you to note. Let's move on to the next subtopic.